North America's transportation and infrastructure system is stretched beyond capacity, making it critical for transportation executives to be able to understand their operational situation to maximize the availability of maintenance of assets, work projects, congestion, and safety, all within the available budget. They need the ability to access and integrate cross-functional data in real time. ROLTA OneView delivers executives a precise yet holistic view of an operation's overall effectiveness and efficiency, along with the tactical data managers need to achieve improvements. Information compiled from disparate systems across the enterprise and presented in dashboard view immediately uncovers critical issues that may impact the outcomes the organization is striving for. ROLTA OneView allows executives to quickly understand what is working, what isn't, what soon may not, and to consider what-if scenarios. Our real-time GIS integration provides location visualization showing where assets and issues are cited, further enhancing operational levels of understanding. The opening dashboard provides an overall assessment on how the organization is doing. The first column we see on the left contains the MAP 21 goals. As we can see, each of the MAP 21 goals, safety, infrastructure condition, congestion reduction, system reliability, freight, environment, and project delivery, are listed in the first column. Against each of these we can see an aggregated score. The data for this demonstration is publicly available data from the West Virginia Department of Transportation. This includes the HPMS that deals with pavements and roadways, NBII that is based on the bridge inventory and condition for the state, as well as FARS, which is the record of fatal accidents for the state. We have used multi-year data wherever possible and have brought all of this information into a spatially enabled Oracle warehouse that we have modeled as a dimensional model to allow the analysis that you see on the screen. Continuing with the screen, the middle column labeled Infrastructure Goals Scorecard contains a few KPIs out of the hundreds that can be defined in this system and that are important to this user. The rightmost column, entitled Available MAP 21 Funding, provides information on funding appropriations as well as amounts that are obligated under each funding program under MAP 21. The notation we are using is called a bullet chart. It is a powerful visualization that provides much easily understood information in a small space. Let me walk you through how to read a bullet chart. For each of the measures, we can see a few things. We can see a target value denoted by a vertical bar. We can see our current progress in the dark blue bar. The current value is also shown numerically as the score. Essentially, it gives a sense of where we are and where we are trying to go. Some measures are presented in reverse. If we look at percentage of congested lane miles during the AM peak, we can see that based on our current data, 40% of our lane miles are operating at level of service D or higher during the morning peak. We would like to bring this down to 30% by the end of this year and actually down to 20% over the long term. Since we are trying to reduce the value of our measure, this chart is presented in reverse. Using the notation, we can also see the various apportionments for the federal funding programs for the West Virginia Department of Transportation. We can see that the West Virginia DOT has been appropriated $259 million under the National Highways Performance Program. Similarly, we can view appropriations for all MAP 21 funding programs. The blue line, or the measure, indicates the amount of funds obligated under each program as projects. At a glance, we can get an assessment of the amount of funds available. As an executive, I am able to understand at a glance how the organization is doing overall with respect to the goals we are being tracked against, certain key performance measures that are important to me in my role, as well as available dollars that I can utilize towards my goals. On the top, we can see three distinct prompts. The first displays the year for which we are showing the dashboard. Users can navigate to a historic point in time for comparison purposes. We are using data from 2012 for this demonstration. The trend prompt helps us understand short-term trends. We are currently looking at year-to-date values based on available data. To support this approach, the data warehouse is continuously updated from the line of business systems to provide information on where we are. Users can select the projected values to see where the organization will be based on current trends, both in terms of short-term predictions as well as project improvements that are on schedule and on budget and that are likely to be completed before the end of the reporting year. Finally, we can also see a list of scenarios that are available to us. Scenarios are outcomes of different funding scenarios. The default is do nothing. The other two options are Scenario A and Scenario B, made up of a different basket of projects selected according to different funding priorities. Do nothing, as the name implies, takes into account the natural growth in traffic, along with deterioration of physical assets such as pavement and bridges, but does not allocate any capital improvements. Scenarios A and B select an overlapping set of projects that are based on different prioritization approaches and then translate the project outcomes to impacts on performance measures. We will review the approaches to project selection later in the demo. Let's continue from the goals. As you can see, the goals display a current score based on some underlying values. I can see that infrastructure condition has a score of 84, but what does it mean? To understand this, we can drill down on the infrastructure condition to see the underlying KPIs that make up the score. On this page, we can see some key indicators for bridge and pavement infrastructure that make up the infrastructure score. Starting from the left, on the top, we can see that 18% of deck area is on structurally deficient or functionally obsolete bridges. In addition, we can see that 32% of bridges greater than 20 feet in length have not been inspected in the state. Further below, we can see KPIs such as percentage of good and poor condition bridges, percentage of good pavement, as well as per mile maintenance cost. On this page, we can also see some more details on bridges. In the center, in the Bridge Deficiency Status column, we can see how the 18% deck area on structurally deficient and functionally obsolete bridges is distributed across the two categories. In the Breakdown by Bridge Count section, we can see how this number has trended over the past few years. Once we have it projected, we can also see how this trend will be by the end of the current year, as well as across our selected scenarios, Do Nothing, Scenario A and Scenario B. Keeping in mind that the overall target is to have no more than 10% of the deck area on deficient or obsolete bridges, we can see on the map to the right how this data is laid out spatially. Looking at the Do Nothing scenario, we can see that if no money is spent, the percentage of deck area on deficient and obsolete bridges will go up from 18% to 33%. And percentage of poor condition bridges will rise to 11%. If we drill down on the poor condition bridges and leave the NHS filter set to NHS bridges, we can see that 237 obsolete and deficient bridges make up that 18% value. Further, we can see the percentage of the results to which each bridge contributes. So if we repair the first bridge, we can hope to eliminate almost 1% of that 18%. In some cases, the improvement cost is recorded. In this case, $18.5 million are needed to improve the bridge. We can also see the location of these bridges on the map. We can filter these by district, urban areas, whether they cross a state boundary or a river, to get to a better understanding when we plan projects. Clicking a bridge on the list makes the map zoom into it, and clicking the bridge on the map displays additional information about the bridge. All the contents of the list and the map pop-up window are completely configurable and can be changed based on evolving needs of the organization or on a specific role. If we switch back to the infrastructure condition dashboard and select the non-NHS bridges filter, we can see how the values change. We can see that 30% of the deck area for non-NHS bridges lies on structurally deficient or functionally obsolete bridges. What's more, we can see on the map that every district in West Virginia has more than 20% deck area on deficient and obsolete bridges. In addition, we can filter the data to a specific district, in which case all the KPIs, trends, and spatial information are filtered down to a specific district. As before, we can drill down to the actual list of bridges by clicking a KPI. We will filter so that all the NHS bridges in District 2 are considered. Then we will drill down on the Poor Condition Bridges KPI. Drilling down to Poor Condition NHS bridges in District 2 results in a list of bridges. We learn that replacing the first bridge would reduce the Poor Condition Bridges score for District 2 to 17%, which represents 0.05% of the deck area on structurally deficient or obsolete bridges on NHS. So we can get a sense of where we are currently and of the projects that represent the best return on investment. Similarly, if we go back to the infrastructure condition page, we can click the percentage of good pavement KPI. We can see that the percentage of good pavement for the state is at 28%, whereas the target is 60%. We are using IRI as a way of measuring pavement quality. Most states will have a PSR, PCR, or PCI to denote pavement condition, and if that data is available, we could utilize that. Since we are relying on the Highway Performance Monitoring System, or HPMS, we are using the International Roughness Index, or IRI. Based on the data we have, if we look at the percentage of poor pavement, the target is to stay under 20%. We are doing well at 3%. In the IRI trends column in the center, we can see how the data has trended over time for both good and poor condition pavement, and we can also see how the data is laid out spatially on the map. We can also select some scenarios and see how values change over the medium and long term. Similar to bridges, we can click the KPI for poor pavement and drill down to see the individual sections that show the worst affected values. We can see the worst pavement along with some of its characteristics. More importantly, we can see poor pavement as a percentage of results. From the Safety Goals KPI page, we can drill down to view the number of fatal accidents KPI. We can look at the worst accidents that have happened in the previous year and filter by any of the criteria. If we wanted, we could also add filter criteria for time of day, day of week, intersection, non-intersection, and so on. More important, we can see roads on the state network color-coded according to the accident rate per 100 million vehicle miles, and we can see the worst areas that need targeting to bring down the accident rate for the state as a whole. Next, we would like to see how we can use the different constraints we have, as well as the targets we are trying to meet, to select the different projects that should be selected. This is the project selection module that allows us to do just that. In the Available Funds column to the left, you can see funds that are available under each of the programs. In the Project goals column in the middle, there are several KPIs we are measuring ourselves on, including safety, percentage of good pavement, deck area on deficient or obsolete bridges, and congestion. You can also adjust the dollar amounts or the targets, and then click Select Projects. The input into the model is a list of projects, their details in terms of lanes added, guardrails installed, median installed, and so on. These are translated to benefits such as reduction in vehicle density during AM peak, new IRI values, updated bridge conditions, and reduction in accident rate. Finally, the optimization model selects the list of projects that meet the criteria and that can be saved as a scenario similar to those we saw earlier. In conclusion, we have seen how we can use ROLTA OneView to understand where we are today, where we are headed in terms of outcomes we are measured on, as well as areas that need intervention as a priority to have an impact on those outcomes. We also could see the impact of our different investment choices under the Do Nothing, as well as a selection of projects under scenarios A and B.